All right, what we're going to be doing here is solving multi-step equations where there are not just one or two things to do, but there are other things that you need to do, such as combining like terms in order to be able to get everything to where you can just do what you've been doing up until this point and solve it. Okay, so we will be using a lot of the same properties, but also combining like terms. Here's that first one, combining like terms. What is the solution of 5 equals 5m minus 23 plus 2m? The trick here is to identify what are the like terms. And like terms look like this. These are m terms. These are variable terms of the variable m. And you can see why we were trying to identify what goes together in Unit 1, because now we're going to be using that and saying we need to combine these. So what does that look like? Okay. First thing that they do here, and I don't mind if you don't do this step of reordering, but the first thing that they do is they reorder this using the commutative property to get these two like terms together. Okay? It's fine with me if you look from here and you can see these terms go together and you just do what they do here, which is to combine them. 5m plus 2m is 7m. Okay? Now this looks like a problem that you've done from the last lesson. And remember, we are undoing order of operations. So we're just grouping everything first together that's alike so we can deal with this just once. We're undoing order of operations. This minus 23 is the last thing that would have happened. And so we undo it with plus 23, do it to both sides. Simplifying that becomes 28. Simplifying this cancels out to be 7m. Now you have this line as the simplified line. And what do we want to do next? Well, whatever's in front of the variable here, whatever's happening to the variable, that's what we want to undo. It's being multiplied by 7, so we want to do the inverse operation, divide by 7. And if you do it to one side, you do it to the other. So 7m divided by 7, that's 7 over 7 equals 1. So you get 1m or just m. 28 divided by 7 is 4. Okay? And then what? Well, we believe we've got our answer, and actually we can go ahead and just box it, because we should always be doing that. And we should do a proof now. So what does the proof look like? Oh, and by the way, this just is a note over here that says, how is this like different than equations you've done before? Now you're seeing the variable twice, and so you can group them. Okay. Here is the proof. And what they do is they start with the original equation, as always. Remember what I said, everywhere you see a variable, you put parentheses and that value inside it. And here you see it twice, so you have two sets of parentheses, one for each time that you see it. First line, original equation unchanged. Second line, exactly the same, but parentheses where the variable is. You're going to hear me saying that over and over and over because it's important for you to be doing it, so you should be doing that. Okay? And now they leave out the steps where they do the multiplication. You should do it. What they should have in there in between is 5 equals, we're allowed to do multiplication on one step. So 20 minus 23 plus 8. We did that multiplication on that step. Okay? And then we can do the subtraction. Typically you write these steps out where you would write 20 minus 23 is negative 3, and then you would have negative 3 plus 8 is 5. But it does check out. And so that's how you do it. Let's take a look at your got it problem. You're going to do both of these by combining the like terms and then solving it like a two-step equation once you do that. Good luck. Okay, we are now dealing with the word problem, so we need to actually write the word problem itself. Okay. Martha takes her niece and nephew to a concert. She buys t-shirts and bumper stickers for them. The bumper stickers cost $1 each. Martha's niece wants 1 shirt and 4 bumper stickers, and her nephew wants 2 shirts but no bumper stickers. If Martha's total is $67, what is the cost of 1 shirt? Okay, so here we've got the things that we'll combine will be the 1 shirt that Martha buys and then the 2 shirts that her nephew buys. Okay, those are like things, and here's the plan that we're going to follow in order to do this. Okay, we define the variable as we need to, right? And what are we doing? We're saying the cost of one item, shirt and stickers, plus cost of this item, 2 shirts, should equal the total. Okay, so you say let S equal the cost of 1 shirt. This kid, by the way, the bumper stickers are $1, so we can say that's 1 for each one. Okay, we don't have to have a variable for that cost. So 1 t-shirt is S, 1 shirt, plus 4 stickers is $4, plus the nephew's 2 shirts, 2S. And since that's the total, we should have an equal sign there. I'm not really sure where it is. So let's put it equals the $67 that Martha spent. Okay, and so we're going to take that and we are going to combine like terms. What they're doing here is they're just reordering things so that the S's are together. I'm okay if you just see the S here and this 2S here and make it 3S. This line, I don't mind if it's not there. Okay, 3S plus 4 equals 67, meaning 3 shirts together plus the 4 stickers, the $4 for the stickers equals 67. We need to take off that $4 first, and then we can say then 3 t-shirts alone cost 63, and when you divide by whatever's in front of the variable, because whatever's happening to S is being multiplied by 3 in this case, you undo with its inverse operation, division by 3. And you get down to a single shirt costs $21. Now I'm going to let you decide whether you want to try the proof on this or not. I'm going to not do it for the sake of time for your video length. Here is your got it problem. Good luck. So you remember the distributive property, right? We're going to use that right now. What is the solution of -8 times the difference of 2x minus 1 equals 36? How do we do it? Well, what we're going to do here is distributive property, so we multiply everything inside by that -8. -16x, positive 8 equals 36. Now we're undoing this. We do that, undo that addition subtraction. Last thing that happens, you write everything the way that it originally was, -8, because that's the action you're taking. 36 minus 8, that's the action you're taking. If you do it to one side, you do it to the other. Combining this, they go away, so you just got the -16x, and this becomes -28. Now, what's happening to x? It's being multiplied by -16. You should not see this as subtraction. You should see this as a negative coefficient. Okay, so it's multiplying by -16. So what do? Divide by -16 both sides. And when you simplify this out, dividing top and bottom by 4, you get -7/4. Okay, and we could box that answer. We don't know yet that it's correct, so I've done a little proof over here, and let me just follow it through. Actually, let me cover it up so that you can just see one piece of it at a time. Okay, first we've got the original problem unchanged. And then we say we're going to fill in the variable with what we think it's equal to, -7/4. And once you put parentheses inside other parentheses, the outer ones become brackets. That's all. The only reason you're seeing brackets there is because you don't have parentheses and then parentheses again. So you put the outside ones as brackets. And we've written everything exactly the same, the grouping symbols and everything. The only thing we did was we replaced the variable with what we believe it's equal to. Okay. Then we simplified. What I did here is I said, what's 2 times -7/4? Well, that 2 cancels out that 4 on the bottom, and we get -7/2. You could also just mentally say, what if I took twice as much as -7/4? We get -14/4, and that simplifies. So I simplified that just here. If you don't know what I'm talking about here, maybe you need some help with fractions. That's something you should ask for. Okay, so this becomes -7/2 minus 1 equals 36. And continuing on, by the way, you notice that I'm not doing the distributive property here. I'm just simplifying using order of operations. Order of operations says do what's inside the parentheses first and follow order of operations inside. So I did the multiplication first. Now we'll do the subtraction. What I've done on this step is we need to, when we subtract fractions, we need to have a common denominator. So I made this into negative 2 over 2 so that it's got the common denominator of 2. Negative 2 over 2 is the same as negative 1. Okay? Now what I can do, what I can do here is say these are halves. So if we have negative 7 and then we take away another 2, we have negative 9 halves. And now since it's down to a single number, there's nothing left to do inside. So we can distribute this in, or just multiply it in rather. And negative times negative is positive. That 8 cancels out this 2. This becomes a 4. So now you have a 4 times 9. Remember, negative negative is positive. 4 times 9, which is 36. 36 equals 36. We did it. That's proof. Here's your got it problem. Just wanted to throw something in here. What they were saying here, when they asked this question, could you, instead of distributing, which works, could you have just divided both sides by 3? Yeah, this is 3 times the entire side. So if you divide that side by 3, that you're going to cancel that out. And if you divided that by 3, you would get down to just, let me write it, 8 equals 3 parentheses 2x minus 6. And if you said, oh, I want to just divide both sides by 3, so I could take 18 divided by 3 equals 3 parentheses 2x minus 6, all divided by 3. And then you would have gotten down to 6 equals just the 2x minus 6. And if you want to solve that and see whether you get the same answer, then you can try that. Okay, this simply says that you can use a couple of different methods to solve equations that contain fractions. We're going to show you that right now. You're realizing that fractions keep coming up, right? So for those of you that need practice on it, you should schedule some time with me to meet during office hours. But we're going to take a look at the 2 methods that we're going to use to solve fractions. All right. So this is the equation, 3x over 4 minus x over 3 equals 10. We can't combine these together because they don't have a common denominator. What's the first method? We're going to write them using the common denominator, and then we can solve it. So what's the common denominator of 4 and 3? It is 12. So you can rewrite this 3/4 x as 9/12 x, multiplying top and bottom by 3 to get the common denominator of 12. And then here we need to multiply top and bottom by 4 in order to get the common denominator of 12. So this times 4 and this times 4 gives you negative minus 4/12 x. That all equals 10. Okay? You need to figure out what the common denominator is, and then you'll figure out what to multiply them by. Then we said, okay, now they're all 12ths. So if we have 9 of them minus 4, we've got 5 of those 12ths as a coefficient on x. And that's equal to 10. Now we're going to do our trick that we know, which is when you want to get rid of the fractional coefficient, you multiply by the reciprocal, and this cancels out. 10 and 5 cancel out, get you 24. Okay, I'm not going to do a proof that. We just wanted to show you that method, is that you can first change it to a common denominator so that you can combine those terms. What other possibilities are there? Let's look at the next one. Okay, here's the other method. The point is to show you 2 methods so that you can pick which one you like better. It's your choice. But here you can clear the fractions. If you multiply by whatever that common denominator would be, in this case, remember it was 12, that 12 will cancel that 4, and that 12, when you distribute it through, will cancel that 3 as well, and then you'll get whole number coefficients. So let's go more slowly through it. First, do the distributive property. Say this multiplies each thing separately, so we're going to rewrite it like that. 12 times 3x over 4 minus 12 times x over 3. You've just distributed that to both things and written them like this. Now, what are we doing here? What you're doing here is you're saying this 12 and this 4 can cancel out, leaving you with 1 and 3, and therefore 3 times 3, x equals 9x. And over here, you can say this 3 and this 12 cancel out, leaving you with 1 and a 4, and there's no coefficient in front of x except 1, so that's just kind of 1 times 4 is 4x. And now, since you multiplied this side by 12, you didn't just change these into equivalent amounts, you actually increased them 12 times. You have to do the same to the other side, okay? Multiplying by 12 is different than just changing the fractions into equivalent forms like on the last slide. So since you multiplied this side by 12, you got to multiply this side by 12, and that's what you get. Now, you can combine them to 5x, and then when you divide both sides by 5, you get x equals 24. And you can notice that that was the same answer, x equals 24. You're going to come up with the same result no matter which way you do it. You should probably watch those twice to see what's going on, okay? So maybe watch it again and then move on to the next slide. All right, so here's your got it problem. And it says, what's the solution and why did you choose the method you used to solve each equation? This is going to be your personal choice. So really, that's kind of all it's asking, okay? But the common multiple of 5 and 4 you need to come up with. The lowest common multiple is best. You can either multiply both sides by that number, or you can change these into equivalent fractions that have both have that number as a common denominator and then add them together. Same thing here. You're going to figure out which of the common numbers, and by the way, this is the thing that goes with this if you're combining like terms, right? I can work this problem with you if you request it so that you can see how to do this, because some kids might struggle a little more with this one. But you're going to find the common denominator and either change them all to the common denominator, or you can multiply both sides by the same thing to get those numbers canceled out. Okay, good luck. Again, this is a point where if you aren't sure what to do here, you should probably schedule some time and ask me. I can show you. Be happy to show you. Okay, finally, and this one is one that actually is not that hard, I don't think, if you understand decimals. When you multiply by 10, you move the decimal over to the right one. And we want to move these over as many times as we need to in order to get them to be whole number, all whole numbers. Okay, that's what we can do. So how many times do we need to move it? We need to move it twice to get this one whole number. So everything got to get multiplied by what? If I say 2 tens, what do I mean? 20? No, I mean 10 times 10, or 100. Multiplying by 100 will turn that into a whole number. Okay, so what does it look like? Okay, the equation contains tenths and hundredths. The greatest number of digits to the right is 2, that you're going to need to move it, so you multiply by 10 to the second, or 100, in order to clear those decimals. This is what it looks like. Multiply both sides by 100. This times 100 is 350. This times 100, remember, since it moves it 2 places, you can see that it's 350. Since it moves this 2 places, it's negative 2x. And since it moves this 2 places, it's 124. And now you're juggling this around. You're saying, I need to undo what's happening to this variable, and the first thing I got to do is this number, that 350, that's being added to both sides. It's added because it's positive. This is a negative coefficient. That's negative 2x. That negative stays there. What you should do is deal with this by getting rid of it so that you're getting all the constants on one side. Subtract 350 from both sides. When you do that, you get negative 2x equals negative 226, and then you divide both sides by 2, negative 2, which is what the number is in front of the variable, to get it down to 1, x, and when you divide that, you get 113. Here's your got it problem. And please, again, you may have trouble with this lesson, so you probably should say, hey, Massey, let's go over this. And you can ask questions in class, too. I have a question and answer for the homework period every time, and maybe that's a good time to do it. Anyway, try this and see if you get it. All right, lots to know on that. You probably want to know whether you did this well or not. So you should try these lesson check problems. Fun fact, there are video solutions for all of the homework set, and you should watch them and figure out how to do it. If you don't know how to do it, you're going to get a lot of good explanations from those videos if you care to know. Okay, try these problems. Good luck.